Hello, it's Paul Beckwith. In my previous video, I gave an executive summary, if you like, sort of high-level information on three Greenland papers, peer-reviewed scientific papers, that I'll be talking about in detail. I'll go through all of these papers. And also on a fourth paper looking at the loss of ice on the planet as a whole. So basically, when there's blocking events, you know that the jet stream gets wavier and slows down as the Arctic warms. And these strong ridges can create blocks. And when this ridge sits over Greenland, then we can have record ice melt loss from the Greenland Ice Sheet, but we also have record low Arctic sea ice for those particular years. In 2019, we set a record loss of ice on Greenland net of 532 gigatons, and that exceeded the previous record melt year of 2012 on Greenland, when, as you recall, we set a minimum in the sea ice, a record minimum sea ice. So, you know, these papers look at the Greenland blocking index, they look at the mass balance on Greenland at different locations along the coastline, you know, as the glaciers retreat, you know, how much ice is lost. They look at the temperature stations and the rise in temperature in the summer and winter on the Greenland coastlines, and basically, you know, look at how much sea level rise is coming from that. The fourth paper, I want to re-emphasize it. The Earth lost 28 trillion tons of ice between 1994 and 2017. That's 23 years. Of that 28 trillion tons, 7.6 trillion tons was Arctic sea ice loss. The Antarctic ice shelves were second highest at 6.5 trillion tons of ice loss. Mountain glaciers were third at 6.2 trillion tons of ice loss. Then followed by the Greenland Ice Sheet at 3.8, the Antarctic Ice Sheet at 2.5, and Southern Ocean sea ice at 0.9. This is not just a Northern Hemisphere phenomena, ice loss around the planet. 60% of the ice loss was from the Northern Hemisphere, but 40% was from the Southern Hemisphere. The rate of ice loss increased 57% since the 1990s, from about 0.8 to 1.2 trillion tons of ice loss per year. Global sea level from that ice loss was 35 millimeters. About 2/3, or 68% of the ice loss, was from atmospheric melting, basically. Warm air temperatures melting the ice. The other third, or about 32%, was ice sheet discharge. So that's composed of calving on the ice, where the ice sheet goes into ice shelves that are floating on the ocean. So calving there, but also melting of the ice from below by the warm ocean water. So about a third is oceanic melt, and 2/3 is atmospheric melt. Overall, the cryosphere has taken up about 3.2% of the global energy budget. So the greenhouse gases trapping all of that extra heat is it's melting, causing phase transitions by melting ice. It's raising temperatures. Okay, it's gonna, as long as there's ice there, it's gonna be melting that out first, keeping the temperature pegged at the melting point. So anyway, that's about a 3.2% of the global energy budget. Of the radiative forcing excess is actually melting the ice. So when there's less and less ice, then the temperatures will rise that much faster. Okay, so now I'm going to get into the details of these papers. Okay, as we move forward here, as I'm sipping on my vitamin juice. Get all my dose from this emergency emergen-c, mix that goes into, any drink. It's a good way to take vitamins. So this was my previous videos. So thank you to David Korn for doing my WordPress. So I talked about the Dansgaard-Oshur oscillations, the warm jumps, and compared that to today. And basically, the idea of abrupt change in the Arctic, greater than 1 degree Celsius rise in temperature. And this is a close-up view. Here we have, this is the data from Northern Greenland Ice Core project. And you can see the data is showing a rise of exceeding 2 degrees Celsius per decade. So, tremendous warming over Greenland. Please check out my blog, paulbeckwith.net. Please consider donating to support my work. This is my Twitter feed. My handle is paulbeckwith. My handle is at paulhbeckwith. This is my website, paulbeckwith.net. And I always share on social media the videos and stuff. And one of the best ways you can help me, apart from supporting my work, is to share on social media my work. But Twitter, Facebook, Reddit, Instagram, anything and everything. Now, just wanted to mention, make a mention for Conrad Steffen, who was at the Swiss camp, and he perished in a crevasse just recently. There's some excellent, so I've been sharing this on Twitter and Facebook and things, and this is an excellent article, in memory, paying respects to glaciologist Conrad Steffen. Must it take a fatal fall into a Greenland crevasse to bring a world-class climate scientist global popular acclaim? And there's some excellent videos. I highly recommend them. On one was from an online course for the European Space Agency, 11 minutes, a 3-minute interview on Peru glaciers with Lonnie Thompson, Greenland's ice sheets, etc., the melting of Greenland. So, he was a great scientist, but he also explained and translated science into everyday language, both for ordinary people and for policymakers around the globe. Not many people do that. Not enough people do that. So I highly recommend that you check those out. And, my Facebook page always loads the stuff going on there. There's some stuff from, I posted some pictures recently from some of the storm chasing that I did. Big, huge storms over Ottawa, etc. So be sure to check out that and my Twitter feed. And one of the things that I did, I was in a sunflower patch and did a video on coronavirus spreading, coronavirus being an indoor disease, and talked about the importance of wearing masks, etc. And I was very surprised by some of the comments, of these people that are coronavirus deniers. I mean, look at the number of global cases. I don't know if this is the latest update. 23,575,000 cases plus. U.S. way out in number 1. Deaths are accumulating. The big concern is as we move into, northern winter, then people spend a lot more time indoors, and coronavirus is an indoor disease, so it just leads, makes sense that, that curve that was suppressed in many countries could end up going back up as a second wave. Of course, the U.S. tried to eliminate this second wave by not ending the first wave. Not recommended, but that seems to be what has happened. Okay, so, what's going on in Greenland with the ice? So this is gigatons here, and this is 2002 to 2020, and you can see the loss. Okay, so look at the huge, okay, so as we go, let's have a look at some things here. So 2007 was a fairly big drop, 2008, although, you know, the other drop years are, there's a big drop there in 2010, there was a big drop here in 2012, very low sea ice years, and look at the plummeting here, very, very low, so record low loss, record drop on Greenland land ice in 2019, and you can see, so here we go, 2010, 2012, big drops. The gap here, the gap is because we lost a bit of satellite coverage when Grace was phased out, and Grace FO then took its place, but there was a gap, there was a loss of some data. So you can see this curve is sharpening, like steepening, and then it slowed down, and now it's accelerating again. So it turns out that these years of record low sea ice also are coincident with a ridge stuck over Greenland, creating a blocking pattern over Greenland, having record Greenland melt, and also there's record or near record sea ice melt in those years. Okay, so, you know, and this is gigatons. Well, how much is a gigaton? You know, what's a gigaton? Just go to Google Images and Google 1 gigaton of ice, and here you see the Empire State Building, and this is a gigaton, this volume here. Or, you know, it's a billion cubic meters. This is Central Park, New York. It would be this high. Okay, if 1 gigaton of ice is a huge amount of ice. You know, here's a view in a city, you know, a gigaton of ice, or if it's vertical, you know, a gigaton of ice. It's just massive, just massive. So 532 gigatons of ice lost over Greenland. That's about 1 million tons of ice per minute, or 7 Olympic swimming pools per second loss. Now, one of the things that is really neat is let's look at the ice. Let's look at images of the melting ice in pictures. This is a great Guardian article. You can just Google the title, Greenland's Melting Ice Sheet in Pictures. Okay, so this is okay, so sea ice in the Arctic, it stays there for the duration of its existence for the most part, typically 1 to 4 years before melting. Some ice escapes to the ocean through a handful of passages, like into the Canadian archipelago, but also out the Fram Strait on the east. So this is the northeast coast of Greenland in July, and this ice here that you see coming down the coastline is exported through the Fram Strait, and it's drifted more than 1,000 kilometers from the Arctic Ocean. So it's hugging the coastline here, and it makes all of these swirling patterns, etc. And it's very thin in some region, and there's open areas, you know, various open areas, and you know, it's fascinating when seen from above by the satellite. This is a Greenland. This is a southwest Greenland ice cap, and it's showing a fjord here. And you can see the fingers of ice coming down into the fjord. This was in 1935, and you know what you're going to see in 2013. This is the image. So the camera lens. We're back a bit further. These hills are smaller because we're further away, but you can count 1, 2, 3, 4 coming down on this side. 1, 2, 3, 4. Right. So it's water here. I mean, we've had tremendous melt. This is chunks of ice floating inside meltwater ponds on top of a glacier in Greenland, and so you can see the ice, and the water looks extremely blue, just like Caribbean water, because it's very, very pure water. That's the natural color of water without plankton in the water, so that's why it's this turquoise bluish color. This is sled dogs wading through water on the sea ice during an expedition in northwest Greenland. So basically, probably the wind and currents and stuff, it pushed water on top of the ice. You know, of course, ice is lighter than water, but the water flooded on the surface of the ice. It's not very deep, but you can see it covers a vast region here, and the sled dogs are wondering what's going on. This is rivers of meltwater on top of the ice draining into these moulin holes, and then they can go right through the bottom of the ice and lubricate the ice from below. I'm going to continue in another video. Thanks for listening.